Okay. Can we hear each other now? Okay, perfect. Thank you. So, hello everyone. My name is Anže, and we're going to take a quick look at what's new in Python 3.14, the so-called Py release of Python. So, if you want to know what's new in Python, you usually go to the What's New page on python.org. And as we can see here by the word count, they're getting heavier and heavier. The latest one has 14,500 words inside, which means that if you're speaking or reading at 130 words per minute, it's going to take you about 2 hours to get through that. Now, in this talk, we don't have 2 hours. I think I have like 25 minutes to get through everything. So instead of reading through the whole document, we're just going to look at some examples, and I'm going to try to make it as interactive as possible by actually running the code in the terminal. So without further ado, let's just jump right in because there's a lot to cover. So one of the headlining features this release is the so-called three-threaded Python. Now, this isn't necessarily new because it was available in previous versions as well. But the key difference this time around is that it is now no longer an experiment. It is now officially supported. And if for some reason the Python community decides to not go forward with this version of Python, there's going to be a deprecation schedule, which means that you can, from now on, you can sort of count on the fact that this is going to be supported for at least, let's say, 4 years. Now, what is three-threaded Python? To best show how this works, I have a very simple example for you all. I have a very inefficient function that computes the Fibonacci sequence here. And then I have a simple thread pool executor that is going to run this function 14 times because that's the number of cores that I have available on this laptop. And let's show how long this takes. First, on the normal version of Python. As we can see, it takes a little bit more. There we go. It took 7.23 seconds. It took so long because of the GIL, the global interpreter lock, all of these 14 tasks were actually executed sequentially. Nothing actually ran in parallel because this function to compute the Fibonacci tasks is CPU bound. Now, if we try the same example using the three-threaded Python, we'll see that it's a lot faster. Now we actually have proper parallelism, and you can see that for certain type of workloads, the difference is huge. So now, in 3.14, three-threaded Python is now in its phase 2 mode, where we as a community have to try it out and see if we can push it into phase 3, which is to make it the default version. And I'm really, really hoping that's going to happen. So if you have any spare time, try to play around with three-threaded Python, see if you can find any issues, report them, and let's try to make this the default in the next few years. Just in case we don't manage to make three-threaded Python the default, there's also work on an alternative approach, which is to have multiple interpreters. Now, multiple interpreters isn't a new concept in Python. You could start multiple interpreters for, I believe, 10 years. There was a C API for this, but only recently, so in the 3.12 release, there was a change made that made multiple interpreters isolated between each other. Before 3.12, they still shared the GIL, so they basically had the same issues as threads do in the normal Python. But since 3.12, there's no more sharing of the GIL here either. Now, why am I talking about this right now? It is because in 3.14, we now finally are able to start multiple interpreters using just Python code. Before, this was just a C API. And the way that it looks, it should look very, very familiar to the code that I've just shown. The only difference is that instead of the threaded pool executor, I'm going to use the interpreter pool executor. The Fibonacci task is the same, and I'm just going to run this to show how it compares. And as we can see, it is slightly slower. Starting a new interpreter is still going to be slower than starting a new thread, but it's still much faster than the default Python version that we have right now. The main difference between multiple interpreters and threaded Python is that the memory is not shared in multiple interpreters. So each interpreter is isolated from each other. So in that sense, it's similar to using the multiple processes, which I also have here just to make all of the examples complete. And as we can see, using the multiple processes is also a little bit slower than the other thing. So multiple interpreters closer to threads in the execution time, but still you have to figure out how to share memory between the threads if that's what you need to do.
Can you run the multiple interpreters under the multi-threaded?
Yes. Let's try. So this was with multiple processes. And this is with multiple interpreters. It still works. Yes, thank you. Okay, so we covered 2 features right now. I don't know how many man-hours of core development time went into this, but we managed to cover this in 8 minutes, so I think we're on good track. So the next big feature of 3.14 are template strings. So what are template strings? They're basically a generalization of F strings that were introduced, was it in 3.8, 3.7? I believe. 3.6, oh my. That was a long time ago. So what's the idea of template strings? The string itself, so the output of a template string is no longer just a plain string. Because if you just have a plain string, you can't figure out what variables you were passed in. You can't do operations on those variables and so forth. So instead, what you get back is a template object. And this template object can then be used to do whatever logic that you might want to do in your program. So in this very complicated hello world example, I'm using a toString method just to concatenate everything together. So what you do is you can iterate over the template object and then simply inspect what type of variable it is. It's either basic string. In that case, we just append it to this results list, or it is an interpolation. And if it's an interpolation, we have access to both the value of the variable, which is in this case world, as well as the name of the variable and some other things as well. And now if we just run this really quickly, oh boy, we get a hello world outputted. Like I said, a very convoluted hello world program. But it's very easy to do like additional operations on those variables, like escaping if you're printing an HTML template, or something trivial like this upper method that I added. So I'm hoping this new template string feature is going to pave the way to new templating libraries and so forth. We'll see what happens. Okay, moving on. So one quite exciting feature is the safe external debugger. So the idea here is if you have a debugger and you want to attach to a running Python process, right now the way that tools do it is by manipulating the memory of the running process, which is extremely unsafe. So thanks to Pablo, who's, I believe, giving a keynote here at PyCon Portugal tomorrow, we now have a way to ask the debugger, or to ask the currently running Python process to essentially run a script that you wrote. This might sound a little bit complicated, but we normal developers don't really have to think about this protocol at all. But what's actually comes out of all of this is that we'll be able to attach to running processes very easily. So this feature is already implemented in PDB, which is the Python debugger. And I'm going to show how it works in 1 second. So unfortunately, in the latest release candidate, there's an issue with this feature on macOS. So what I need to do is jump into a Docker container so that it will actually work. I believe this is going to get fixed before the latest, the final release, but look, I'm showing you things that are still not finished correct until completely. Okay, so what this script does, it's just a Python program that counts and then sleeps a little bit. And I'm going to run it. And now that I've run it in the background with this ampersand here at the end, I also received the process ID as the output, which is very useful. And now what we can do is run the PDB module with this new parameter called P, and we can specify this process ID. And here we go. We're inside the running program. We can now print out the counter, and we can get out of it. I mean, we can pretty much inspect whatever is going on inside the program. Yeah, it's pretty awesome. Okay. Let's move on. So in a similar fashion, we also received tools to inspect async I/O processes. So if we have this sort of a program running, so this is essentially a program that starts a few async tasks. And if I run it the same way as I ran the first program, now I have the process ID 10. I can see exactly which tasks are in progress and what their state is by using this async IO ps3 command with the process ID. So debugging live systems in 3.14 is going to become a lot easier than it used to be, which is pretty awesome. Okay. So one other new feature that has been added is the Z-standard library, which is a compression library developed by Facebook. And this was added to the Python standard library, along with a new namespace called compression, where now all the libraries for compressions live. So we have VZ2, gzip, LZMA, zlib, and now zstd, the new one. And this is just a silly program trying to compress the hello world string. And we can see that pretty much all of the libraries do a very poor job because the original is 11 bytes and all the others are more. But of course, if we make this a little bit more interesting, we'll actually see a difference. And we can see that Z standard, so the new one, does seem to compress the most out of all of the ones that we have. So I think also a good addition. Oops. Okay, there has also been a syntax change to Python itself, although it is kind of minor. So before 3.14, if you wanted to have multiple exceptions in an except block, you had to have parentheses around them. But now this is no longer necessary, even though of course, my editor hasn't caught up with the latest progress here. And as we can see, let's run it on 13 first, and we see that we get a syntax error. But in 3.14, it will work. So minor, but it does clean up the code a little bit. Okay, going forward to probably my favorite feature in the latest Python version, which is deferred evaluation of annotations. So if you're like me and really like to put types in your programs, you probably ran into this issue in pretty much every Python version until this latest one. So let me just show you the error, and then we'll talk about it. I wanted the old one. So the issue is that I made a type annotation for a thing that hasn't been defined yet. So attendee is defined down here, but here in the conference class, we don't know that the interpreter hasn't seen it yet. So the type is not defined, so this sort of errors out. Now there's a couple of ways to get around this in the current Python version. You can make the whole thing a string, and then it's going to work, but it does look ugly. And you can also use from future import annotations, which essentially does what I just shown for you automatically, so converts everything to strings. And that makes the annotations lazy, but it kind of broke a few frameworks that were just starting to pop up when this was introduced. So these were like small frameworks like Pydantic and FastAPI. I don't know if you've heard of them. They might have grown a little bit since then. But the idea that this future import annotations would become the default was essentially a death sentence for this kind of frameworks that used annotations at runtime. So this idea was kind of scrapped. And in 3.14, from future import annotations is actually deprecated. It's not yet removed. It will only be removed long time from now. But what happened was, so the change was still made that in 3.14, as we can see, we can just run it and there are no errors. All of the annotations are lazy by default. So they work as one would expect. But the difference now is that if you're a framework developer, you're going to have to do a little bit of work to support this. And for that reason, there was this new package annotation lib added that has a very useful function called get annotations. So if you need to inspect what the annotations are, you can use this get annotations function to figure out what you have here. And you have a couple of different formats. So string is essentially the same thing that you would get if from future annotations were set. But you also have value that will show that will actually give you the proper value of the thing. So super useful for us people that use frameworks, a little bit annoying for people who write frameworks because they're now going to have to support all of this. But all in all, I think this is a really good change for Python itself. Okay, and now moving on to improved error messages. Starting with this one, and I don't know if you saw Pablo at lunch today, if he was sitting on a chair trying to debug something very furiously. He was trying to debug this issue that I showed him here. So in the latest version of Python, okay, what did I do? In the latest version of Python, we now have, oh no, where did I go? Help. Okay, we're back. We now have some more helpful error messages, but it turns out that there's a bug and the helpful error message doesn't always show up. So let me just show you how the message looks like. So if you made a typo in one of the keywords, Python will now tell you that there's an invalid syntax and tell you like which keyword you probably mistyped. So here we go. While instead of will or whatever I wrote there. And this is super useful for beginners that are just starting out and might not see what they did wrong. But yes, this doesn't fully work if you run the thing in the script like I'm doing here. So as you can see, the error message doesn't pop up, and that was what Pablo is probably trying to fix right now. So sorry about that. And there's a few other cases when like pretty much every keyword in the Python language now supports this. So this is pretty awesome. There's a few other minor things, like if you try to unpack something where the number of things doesn't match, you're now going to get expected 3 but got 4. Also useful if you accidentally put an elif block after the else block, it is also going to tell you that now very verbosely. And there are a few more cases like this, but I fortunately don't have the time to go over all of the cases. Moving on really quickly, there are also a lot more colors everywhere. So another cool feature for pretty much everyone, especially for beginners, because this looks a lot more friendly than the old sad version of ArcParse. And the same goes for unit tests that now actually look a lot more like PyTest default output, but before it was just sad and dark like this. Okay, these are the main ones. There was also a syntax change that's currently just a warning. So if you have a return statement inside a finally block, that can be very confusing because I don't know if you ever thought about it, but if you have multiple return statements, like in this example, it's kind of hard to figure out which thing is actually going to get returned. So in this latest version of Python, there's now a syntax warning that you probably shouldn't do a return in a finally block. And this is going to become a syntax error sometime in the future, so try not to do that. You'll just get confused in any case, so best not to. Okay, now there are 3 other important features that I'm going to cover, but there's not an easy way for me to show how they work, so we're just going to look at some slides from now on. The first one is a new type of an interpreter. So this one stirred quite a bit of a news cycle around the Python in the Python community, because first when it came out, it was said that it has 9 to 15% performance improvement, but unfortunately for us, that was an issue in how they benchmarked the change. So in reality, this should improve Python for only like 3 to 5%. Which is, yes, it's smaller than the 3 to 15%, but still quite an improvement. It is opt-in for now, so and only available in some of the platforms, so you might not see it just yet, but I'm pretty sure this will become a default sometime soon. Speaking of performance, there's also now binary releases for the experimental just-in-time compiler available. And this is also going to make your Python programs faster in some cases, maybe slower in others, because this is still a work in progress and not intended for production. And finally, there's an incremental garbage collector, which means that when Python does the cycle garbage collection, it is now incremental, and it's going to stop the world for a lot less time than before. So again, your programs should run faster without you having to do that much to make it so. And that's all that we have time for. There's a lot more features. If you have the time, go read the What's New doc. But other than that, maybe we have some time for a few questions.
Yeah, we have time for one question before going to break.
Okay, so hopefully it's going to be a good one. I
No
wanted
pressure.
I wanted to ask you, in your point of view, what's the advantage of the interpreter pool instead of multiprocess? Like you said, it doesn't spawn additional processes, right? So
Yes.
it probably runs a separate interpreter in each thread.
So the way that it works, each interpreter, so it doesn't, like you said, it doesn't spawn its own process, but the interpreter itself is isolated from every other interpreter that you spawn. So,
But then the memory footprint is basically maybe about of multiprocess.
it's probably, at the moment, it's probably closer to multiprocessing than to threads, of course. And it's probably going to be like that for a while. But so in the release notes, they do say that they will try to reduce the memory footprint of each interpreter. So in theory, maybe not in this 3.14 release, but in the future, the memory should be lower when using multiple interpreters compared to multiple processes.
And last sub question: how do you think data sharing between these interpreters will work? Like in multiprocesses, we have like queues in threads also, but
yeah, it's up for the community to discover that. There's, I believe, there's a module called memview or something like that they're working on to make this easier. But in the 3.14 release, there's no official way how you're going to share memory or pass things between the interpreters. So it's up to you to figure that out. But I believe that there are people that are very interested in this. So if you look at the space and the PyPI packages that are going to pop up to support multiple interpreters, there are probably going to be all sorts of solutions on how to share memory between the interpreters. I just haven't went too deep into this yet, so I can't tell you the specifics.
okay. Thank you for the talk.
Welcome. Thank you.